Good morning, Tarun. Good morning, Sharmila. Just 1 minute, beta. I'm sharing the link to everyone. Good morning, Porane. Good morning, children. Now look here. Today, first, what we are going to do is we are going to study some examples, some questions, MCQ questions, and then we are going to proceed to the class. Okay? Good morning, beta. Everyone, please inform the group to join the link. I have shared the link in the group. Come on, go for it, beta. Shall we start the class, please? Siddharth, good morning. Okay, now let's start the class, please. Okay, now we are going to understand one question is there. These type of questions when coming in examination, how we are going to attempt the questions and how we are going to solve and write in the best way. Now, the first question what is given to you, can you check a beam of light is incident through the holes on side A. So this is side A. Okay, this is side A and beam of light is entering through the holes of side A. Got it? And emerges out of the hole on the other face of the box as shown in the figure. Now the light ray is entering like this, but it is coming out in this way. As shown in the figure. Which of the following could be inside the box? Means inside the box there may be a lens. Good morning, beta. Good morning, Darshan. Good morning, Kavya. Good morning, Jotam. All the children, good morning. Now come on, answer this question. Which of the following, which lens can be inside? Is it a convex lens? Is it a convex lens? Is it a concave lens? Is it a rectangular glass slab inside or is it a prism? So what can be the correct answer? You children have to answer. So Kavya and Sharmila has given option D. Kavya and Sharmila has given option D. All the children, those who are present online, they have to type their name and send immediately that they are present in the class, please. Come on, go for it. First, inform quickly. Option D. Good morning, beta. Good morning. Good morning, everyone. Kavya, I present. Okay. Now everyone has given answer D. Can anybody tell me what is the reason behind? What is the reason behind? Good morning, Maha. What is? Where is Anu? Bhavya, good morning, beta. Now you tell me one thing. What is the reason behind selection of option D? Why you cannot have told? Means you could have told concave lens. You could have said any other thing. You could have said prism. You could have said rectangular glass slab. But you have said convex lens. What is the reason behind saying it as a convex lens? Convex lens is converging lens. Convex lens is converging lens. Okay. Convex lens is converging lens. Convex lens is a converging lens. Absolutely correct. So convex lens is a converging lens. Because of that, it is exactly coming. Ashish, good morning, beta. So convex lens is a converging lens. Correct only. So because of that only you have given this answer. Come on, say this. The correct answer is yes. It is clear and you have to see that the convergence points at a point of emergence. So 100% the answer is absolutely correct. We'll go for the next question, beta. Which of the following statement are true or is true? Let's see. We are going to see the statements. Is or are. Anyone can be true. Can we see this part, beta? Can we see this part? Come on, go for it. Ashish, good morning. Where is Satya Sai? Come on, go for it. Which of the following statement is or are true? You need to identify which statements are true. Now let's check this one out. A convex lens has 4 diopter power having a focal length of 0.25 meter. Okay, this is the first part what they are telling. Here, okay, what is the answer? Come on, check this one out, children. Come on, you can do it. Which of the following statement is or are true? A convex lens has diopter power having a focal length of 4 diopter having a focal length of 0.5. Mahalakshmi is telling option B. A convex lens has minus 4 diopter power. Come beta. A convex lens has, go down and go. Camera. Come on, Jotam has given option B. Bhavya has given option B. Kritika has given option B. Come on, you can do it. Come on. Kritika, Jotam has given option B. Okay, Sharmila has given option B. All the children are giving option B. Divya has given option B. So what is the question here is which of the following statement is or are true? So we need to identify which statement is true. So a convex lens has 4 diopter power having a focal length of 0.25. A convex lens has minus 4 diopter power having a focal length of 0.25. Now a concave lens has 4 diopter power having a focal length of 0.25. So which answer is going to be correct? Say. Harini has given answer A. Where is Arun? Okay. I hope all the children has given answer A, B. A convex lens has, again and again I'm saying this part, I hope you might have understood why I'm repeating the content. You people are directly going to the content, but I really want you to understand something. I'm saying the correct answer is not, see, a concave lens has minus 4 diopter. I have just given you the answer. You just check the answer is not A, the answer is not B, C, D, the answer is A. Now, can you check one thing? Now, can you go for it, children? Yes. Now, you are exactly getting the answer because I have shown you the answer. Now, please check this one out. How to understand this one? Okay. The simple concept I am going to explain you. Convex lens has 4 diopter power. What is convex lens? Convex lens focal length will be here in front or in back. So here you know that the focal length of the convex lens will be exactly positive. Understood? So here you need to see the sign positive. Convex lens has 4 diopter power. That is plus. Correct only now. So we can directly solve and we can directly write the content. What is there to go here and there? Directly we are writing that we know that focal length is equal to 1 by power. So here when we are writing this one, so here directly formula is coming. So 1 by 5 is exactly coming as 0.25. That's absolutely correct answer. So no need to go here and there. Understood? Now this is a very good question. Come on, go for it. Magnification produced by a rear view mirror fitted in vehicle is less than 1, is more than 1, is equal to 1, can be more than or less than 1 depending upon the position of the object in front of it. This is seriously, hi beta, hi Krish. Anu, good morning, beta. So now this type questions when coming now, please kindly read the content and solve. So here, what is actually the question is, so how we are going to understand first one, placement is little problem. Yes. Now can you say what is the answer, beta? Option is D. How the option is D? Come on, check very nicely. Is the option D? Come on. Is the option D magnification produced by a rear view mirror fitted in vehicle is less than 1? It is less than 1, is more than 1, is equal to 1. See, there is one concept now. We know what type of mirror is fitted in a rear view mirror. Can you say what type of mirror is fitted in rear view mirror? First, after that, we will do another one. Concave or convex? Concave or convex? What type of mirror? Come on, type and send children first. So first we will understand that one. After that only I will be answering you this question. First question what I am asking from you is, after that we will go for refraction concept and we will again revive because first 5 questions First 5 or 6 questions of revision we can do in physics. After that we will go. So magnification produced by a rear view mirror fitted in a vehicle. First, though, what type of mirror? Come on. What type of mirror we are talking about? What type of mirror we are talking about? Can you say? What type of mirror we are talking about? Concave mirror or convex mirror? After that only I'll accept your answers. Concave mirror or convex mirror? Convex mirror. Absolutely correct. Absolutely correct. The answer is convex mirror. Krish, absolutely correct, beta. Everyone has given a correct answer. Why, beta? Because here one thing is there. We must understand that when we are talking about convex mirror, here whenever image is obtained, the image is always virtual and erect, and it is smaller than the object. Understood? But so whatever we are perceiving, so whenever any object is very far, understood, it is exactly far, it looks more far. If it is in rear view mirror, actually the distance is looking far but the vehicle is slightly near. Understood? So it's like, why? Because you want to have a total back view. Understood? For that only we are putting what mirror? Convex mirror. What we are putting here is convex mirror. So 100% when image is smaller than the object, then magnification will be less than 1. So there should be no doubt about it. Understood? So directly we can say the magnification here is less than 1. The magnification here is less than 1. Understood? So here it is a convex mirror. So now we are going to go for the next part. Come on. So full length image of a distance tall building can definitely be seen by using a concave mirror, a convex mirror, a plane mirror, both concave as well as plane mirror. What is the correct answer? Ayush, good morning, beta. Good morning, Ayush. So now look here. Please tell me the answer. Please tell me the answer. So if somebody will be asking you this question, how you are going to answer the question? This is a simple part. Please kindly go for it. A full length image of a distant tall building can definitely be seen by using what type? Can you say? Concave or convex? Will there be any confusion related to this question? Because I don't think there is any confusion related to this question. This question is a clear cut question, children. Come on, go for it. A clear cut question is there. Yes, Krish? Yeah, doubt is there. Krish, can you ask? Can you ask, beta? See, we want a clear picture and we want a complete picture. You know that concave mirrors are converging, convex mirrors are diverging. Understood? Concave mirror, most of the time, the image is exactly obtained real and inverted. Okay? Real and inverted. Magnification will be after the object is exactly kept after curvature only. At curvature, the image distance will be equal to the object distance. At curvature, the image distance will be equal to object distance. This I am talking about concave. Understood? So, whenever we are going to talk about, only one case is there in concave mirror where the image obtained is virtual and erect, when you will keep the object between focus and pole. That means what? The object has to come very near. That's the case. So here now I think everybody started discussing correctly. Super. So after getting that concept, I hope everybody started understanding. So now plane mirror, how can it be? Plane mirror means half, we need half of the length of the object, so only plane mirror can have a full image of the object. Understood? So the real answer is which one? Can you say me? After these many confusions of B, C, D, see, like these questions are coming in board examination, then 100% you will confuse everything. Correct now? You people are going to confuse. Now you give me the answer. Both concave as well as plane mirror will never be the correct answer. How can be? Concave and plane mirror will never be the correct answer, children. So what can be the correct answer? A plane mirror? No. A convex mirror or concave mirror? So let's see. This one will never be the answer. This one will never be the answer because plane mirror, no. So this one concave mirror will never be the answer. Now we are going to talk about convex mirror and plane mirror. So plane mirror, no, because half of the image, like if I want to track out, I need half. Why we use concave mirror for makeup? Because beta you need to go very near to the mirror, sorry, concave mirror, because you need to, that time the face will be kept near focus and pole. Understood? That big size, na, big size mirrors are there. Yes. Understood? I hope you might have understood this one. Children, understood what I have discussed there? Huh? See, they have given the answer also. Convex mirror has a wide view field of view as it forms virtual, erect, and diminished image. Hence far off object and hence nearby object. If we want to see, we can see like that. So there are many things we need to discuss. See, very clearly answer has been given. So if you want to know about the length, we can be exactly using convex. Now go for this question, beta. What is the question is, in torches, searchlight and headlight of vehicle, the bulb is placed between the pole and the focus of reflector, very near to the focus of reflector, between the focus and center of curvature of reflector, at the center and curvature of reflector. Beta, this answer everybody knows. You people are knowing the answer. Come on, check. You people are knowing the answer. First, read the question very carefully. My advice is read the question very carefully. Yes, now Chris, try to answer this question, beta. Read the question very carefully and try to attempt the question. Come on, come on, come on. You can do it. Everybody is telling option is A, between the pole and focus of the reflector. Uh, Come on, at least some answer you give. After that, I will be rectifying it. Give some answer. After that, I'm going to rectify it. But at least give some answer. Type correct, wrong, just whatever is coming in your brain, just type. After that, I'll take care of it. Answer is A. Many are telling answer is A. Some are telling answer is B. So now can I explain now? Can I start my explanation work? Yes, Kavya, everybody. Now listen, beta. I'm going to explain this. Please be attentive. Listen me very carefully. I'm going to explain this one out, beta. See, first between focus and pole. So when an object is kept at focus, the image is obtained at infinity. We know this now, कि when an object is kept at focus, the image is obtained at infinity. Object kept at focus, image obtained at infinity. Understood? So if I am going to keep bulb at focus, the rays will go till infinity. Are you understanding the concept now? Now you can answer. If I will keep the bulb near to focus, the image will be exactly going till infinity. So which is the correct answer, beta? The correct answer is we are going to keep the bulb near focus so that the rays will go till infinity. So now I am going to draw this one so that your confusion will get clear. Now look here, beta. So here, if I am going to keep the object here, if we are going to keep the object here at focus, understood, the rays will go like this, correct? And if it is crossing like this, it will go like this. So image will be exactly obtained at infinity. So 100% it will going to go very far, huh? The rays will go very far, and that's technically the correct answer. That's technically the correct answer. I hope you might have understood this one. Come on, go. We will be discussing about the second points. So now I'm going to start reflection, because this much we have discussed, some questions we have solved. This is seriously a very good question. The law of reflection hold good for plane mirror, concave mirror, convex mirror, all mirror irrespective of their shape. Now let's see. Rishabh, what is the correct answer, beta? Good morning, Rishabh. Now look here. The plane mirror is exactly the law of reflection hold good for where? Where? Only concave mirror, convex. That's a very cool answer. Everybody has exactly given answer very fast and very good. Super beta. The correct answer is all mirror irrespective of their shape. That's the correct answer. Yes, correct, Krish. Absolutely correct, beta. Rishabh, absolutely correct. The correct answer is D only. Why, beta? Because we know that each and every single ray, they follow law of reflection. Each and every single ray follow law of reflection. I hope you might have understood. Everyone understood or not. So every single ray, see, understand one thing, beta. Manju, we will understand one very simple concept here. The concept is कि when we are talking about, see, first though, reflection is a surface phenomena. Understood. Second is कि it is about the beam of light falling on a surface. Okay. Now, the surface has to reflect back the rays. So if the beam of light is coming parallelly, now look here, beta, just 1 minute I am explaining, children. So if the beam of light, see this is a smooth surface. So if this is a smooth surface, beta, and the rays are exactly falling parallelly. Now smooth surface, each and every ray follow law of reflection. Our law of reflection says what, beta? Angle of incidence is equal to angle of reflection. Correct, na? Now look here, these rays will exactly have normal here. So angle of incidence is equal to angle of reflection. So every ray will exactly follow law of reflection. How much angle they will be making incidence, that much it will be making for reflection. That part we have already known about it. So this is a smooth surface. But what about the rough surface? In rough surface, so that means what? In rough surface, when the ray of light will be falling, in rough surface, when the ray of light will be falling, beta, the ray of light will be falling again parallel. The ray of light will be falling parallel. It is the nature. Please remember this one. But this will exactly come out like this. Understood? Then you will say that this is exactly called as scattering. This is exactly you, me, everyone is visible because of this scattering. These are exactly scattered rays, which is a scattering an object which is not having a smooth surface, but law of reflection hold good for each and every single ray. Understood? So every single ray will follow the law of reflection. Angle of incidence will be equal to angle of reflection. Because this is the most important concept we must understand. I hope my children understood this one. So either the rays will be falling concave, convex or plane mirror, all different type of mirror, all different type of surface. Our body, everywhere, they will follow what, beta? Law of reflection. Each and every. Together they may not be able to come out as parallel beam. Understood? When the surface is not smooth, together they may not be able to come out as a parallel beam, but they will follow law of reflection. That's the most important point, beta. Good morning, beta. Onati, good morning. So that's the most important point to remember. They will follow what, beta? Law of reflection. So that means each and every. Laddu Pio, good morning, beta. So each and every ray of light will follow what, beta? Law of reflection. I hope you've understood now. Manju, understood? So this is one of the most important concept, beta. We need to understand. So option is absolutely. Beta, I teach maths, chemistry, physics, biology till 10th class. My specification is like that only. I'm what you call PhD. I'm doing PhD in maths. I have done B.Ed in what you call both maths and science. I'm top 10 ranker of university. Understood, beta? So we can understand it with much easier content. Understood? So we are not going to make it tough, we are going to make it very simple and try to understand. Lokesh, good morning. Lokesh, yesterday you gave me some questions now. Shall we go for this question, beta? I don't know. You people are going to say the answer. Can we see this one? The path of ray of light coming from air passing through a rectangular glass slab traced out by four students are shown as. First, I will show you first and second one. Good morning, beta. First, I will show you first and second one without seeing all the four. Please kindly don't go for any conclusion, children. Okay. Now look here. The path of ray of light coming from air passing through a rectangular slab traced by four students are shown. So the first student is showing this one. Seriously, the student will be very intelligent. Okay. Now second one is shown like this. Okay. Now third and fourth we are going to show you. First and second, make up your mind which one is the correct one. After that we will discuss. Make up your mind, first one. So refraction concept, make up your mind which one is exactly correct. So here now this one, second one. Now we are going to see the third and the fourth one. Oh, without seeing third and fourth, the student started answering the question. Super, beta. Super, super. Very good. The correct answer is B. Absolutely, children. The correct answer is Sufi. The correct answer is B. Okay, absolutely. Shakti, correct answer is B, beta. Absolutely correct, beta. Absolutely correct, Bhavya. Everyone, where is Lokesh answer? Where is other children answer? Manju, where is the answer, beta? So answer is absolutely B. Why? Because here if we are going back to our question, can we see beta, we need to draw. So when we are drawing here, we are understanding one thing. We know that when the ray of light will pass from rarer medium to denser medium, it will bend towards the normal. So here it is exactly, it should go like this, but it is bending towards the normal. Understood? And when it is coming out, it will bend away from the normal. So it was supposed to go like this, but it bent away from the normal. So since it is bending away from the normal, it is bending away from the normal. First, it is going towards the normal when it is going from rarer to denser medium, and then it is going away from the normal. That means what? It is a perfect. So this one is the perfect one. I hope children understood this one. So now we will go for refraction related questions. The correct answer is B only. Now beta, I'm going to go back to the content because we need to now. So nearly 5 to 7 questions I have revised, important questions. Now we are going to study about our refraction concept. Now children, are you ready? Are you ready to answer my questions? Come on. Don't stop. Keep answering. I have asked that, I have discussed in last class some of the most important questions. Children, are you all ready? Come on, say first yes. Just press the live button so that all will be exactly at the same time. We all will be answering the question. Come on, fast. This is very slow. Very slow. Very, very slow. You need to be very fast. Yes, yes, yes. Now I'm getting all answers. Now, children, listen. Ranjit, ready? My question is, if I talk about optical density and density, are they both same? Good morning, Strawberry. Now look here, beta. Are they both same? Come on, fast. Are they both same? I talk about optical density and density. Are they both same? The first answer, say fast. Optical density and density. Are they both same? Jotam Shakti has given the correct answer. First answer, they are not same. Okay? They are not same. They are not at all same. Yes, absolutely correct, beta. Strawberry, everybody has given the correct answer. They are not same. Hasini answer is no, absolutely correct answer, beta. So we were discussing about optical density, and let me go back to the question part. We were discussing last time, if the speed of the rays, if the optical, good morning Rudra. Hi Rudra, late today? I'm going to I'm going to reply with a hi. Now listen, we are going to go back to the content, Rudra. Come on, start answering the question. Children, what is my question is, my next question is, if the optical density, Listen very carefully. Optical density of a medium is high. Will the rays speed will be less or more? Less or more? Come on. Yes, I'm teaching also offline, beta. Come on, come on, come on, come on, come on, fast, fast. First answer I have collected from Kavya and then I have answered. Here, children, come on, answer the question. What is exactly the answer? Absolutely correct. The answer is absolutely correct. The optical density decides, because optical density is what? The particles that is present inside the medium will be the one who is responsible for allowing the rays to go inside it. Understood? So optical density work for that. Absolutely correct, beta. All those who are given answer is less, they're absolutely correct. So optical density decides what? The optical density is deciding the rays will be having higher speed or lower speed than the usual one when they are entering from one medium to another medium. When they're entering from one medium to another medium. So 100% the speed will be less if optical density will be more. Understood? So optical density is the intrinsic behavior of the particles, that the particles will allow the light rays to enter or not enter. Understood? So higher optical density, lesser will be the speed. Higher optical density, lesser will be the speed. That means we have understood this one. Come on, next question I am going to ask. What about the bending? When optical density is higher, will the bending will be more or less? Ranjit? When optical density is higher, will the bending will be more or less? Come on children, answer fast. When the optical density is higher, the bending will be more or less? Yes, the correct answer. Now Strawberry, everyone has given the correct answer now. When the optical density will be higher, the bending will be more. The bending will be more. Understood? So it will bend towards the normal. It will exactly or bend away from. So optical density higher means the medium is denser. Optical density higher means the medium is denser. Very good. All of you are correct. The optical density higher means the medium is denser. Come on children, I am asking the next question. When the rays are entering, listen very carefully. When the rays are entering from a rarer medium to denser medium or a denser medium to rarer medium, does all the rays enter at one time? Does all the rays enter at one time or one by one? Enter at one time or one by one? Come on, say beta. Enter at one time or one by one? Very good. Absolutely correct, beta. They will be entering. So only the speed varies. And because of the variation of the speed, where Varsha, good morning, beta. Because of the variation of the speed, what we have seen, because I'm repeating, because of the variation of the speed, we are exactly, because package one went, other after that sometime another one went, after that some package is exactly entering. So only we can see that diversion is there, bending is there. I hope this is absolutely clear, because already we have discussed these concepts and we have discussed about lateral displacement. Lateral displacement is one of the concepts where we have discussed a very important point. The important point what we have discussed in lateral displacement is the usual path of the ray of light will be a straight line when the rays are exactly going from one medium to another medium. So what is our expectation and what is the reality? There is a much diversion in that. Understood? Yes, 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 absolutely correct, children. Let's check this one out. This ray, which is exactly entering from a rarer medium to a denser medium, it was supposed to go straight. But is it going straight? No. The moment it entered from rarer medium to denser medium, it bent towards the normal. And when it is bending towards the normal, when it is bending where, beta? Towards the normal, the diversion means it will exactly not going to go in the straight line. Understood? So when it is bending means angle of incidence and angle of reflection will be exactly different. Understood? So since angle of incidence is different from angle of refraction, what will happen? The ray will not be a straight path. Understood? And again, when they are coming out from rarer medium to denser medium, I am both, beta. I am both. I'm teaching in school also, and I'm running coaching also. Now look here, beta. So shall we get back to the work? So here we have to understand this section. I'm not serious, beta. I'm just trying to give you the best in very less time so that your time will be utilized very nicely. Okay. Now listen. Your time should be utilized and you should be getting some fruitful content, beta. So only. Now listen, so when we are drawing the rays, so here you can see that the rays are exactly going what? Bending towards the normal. So the rays are bending towards the normal. Thank you so much, beta. God bless you. I'm trying my level best. So now look here, beta. The rays are bending towards the normal, and it is going to come out from a denser medium to rarer medium. And once it is exactly coming out from a denser medium to a rarer medium, it is going away from the normal. So the real path and the apparent one. So there is a difference in that. Understood? So we have exactly concluded that there is a displacement here from the actual and the real one. So apparent one means the expectation was this straight line and the coming out emergent ray will be exactly different, and they are making, so angle of incidence is equal to angle of emergence. And beta, when angle of incidence, so we have given a very important thing, Saifi. Okay, beta, I'll try my level best. If I'm not teaching good means I'll try my level best to teach good, beta. So now please understand this one. So when we are talking about the ray means actual path and the one which we have expected, so there is a displacement between them, and that displacement is called as what, beta? Lateral displacement. I hope you might have understood this one. Now we will go for the next one. So already we have discussed about most of the things. Lateral displacement, yes, beta. Yes, lateral displacement, we have already discussed most of the part. So falling normally. So what will happen? Now one question I'm going to ask from all of you. Yesterday one question I have asked, because these type of questions will create problem for you when we are discussing. Easy questions now. Right now I'm teaching better questions we are going to discuss now. Now we are going to understand refraction of light. Refraction of light already we have discussed. Bending property, because right now I am teaching better. Regularly classes are going on. So right now teaching, after that numericals we are going to take. So only. Now look here. So if a ray of light will fall normally, will there be any bending? Good morning, baby. Will there be any bending? So if any ray of light will be there. So right now we are just in the explanation section, beta. When explanation will be there over, after that only numericals I am going to. So first once explanation will be done, then only numericals will be done. Okay. So now let's check this one out, beta. Let's check this one out. So these are exactly normals. If the rays of light are also going like this, will there be any bending? The answer is no. Absolutely. Good morning, Vibhu. So answer is no. The answer is no. So if the incident ray fall normally or perpendicular to the surface, there will be no bending of ray. So this is one concept we have exactly going to come to know. Now we are going to talk about numerical speed. We are going to talk about Snell's law. We are going to solve some questions also. Very good. Answer is approximately, no. Who is telling that? Yes, first we will understand the easy one, then we will go to that. Because numericals also I have to make easy. So once your concepts are easy, you will be able to answer any level question. Okay, that's my concept. Because real physics is not there in book. Real physics is in nature. First we will understand and then we will do it. Absolutely correct. Now we are going to go for the next one. Please kindly pay attention and do. A stick held obliquely and partially immersed in water appear to be bent at the water surface. Appear to be bent at the water surface. I want my children to answer this question. Come on, you people are ready for answering this question. You are seeing an image, you are seeing everything is exactly done. Apparent and real. Apparent and real. What is the difference between apparent and real? And when it is happening? And why it is happening? The three question: when, why. What is three question I have asked? What is real and apparent, when it is happening, and why? Come on, you can answer, because I believe children can answer questions. Refraction. Okay, very good. Refraction is the answer. Hmm. Refraction. But beta, if somebody will tell you to explain without using chat gpt, without using google, if we want to answer, what is the answer? We must answer in our own concept way. So we cannot use anything. Don't use any tool. Try to answer in your own. Because of refraction it bends. Absolutely correct. Because of, give me some simple answers. I'm not expecting a very high level answers, and that should not be given. You should be giving some answers which is exactly fitting in your brain. So what is our real expectation is this one. Understood? So when we know that the light will be traveling from a rarer medium to the denser medium, so the here bending starts. Can you see this part better? So if I'm going to draw one, so first let's understand in a very simple way. After that only. Now look here, beta. First this one and this one. So when we are exactly going to see, can we see this with other color? Now look here, this one and this one. So when we are exactly, what is the actual one? So if the rays are exactly coming like this, it should go like this. This is our expectation, correct now? But it is not like that. When the rays will enter from one medium to another medium, it will bend towards the normal. It will bend towards the normal. Understood? So it is going to bend towards the normal. Exactly, it is bending towards the normal. So when it is bending towards, the moment the bending is will start, the real one will not be seen. Understood? Apparent one will only be experienced. So only we can see a straw or a pencil. It is looking like it is broken, but it is not actually broken. It is because of the refraction, it is appeared to be broken, but actually because the real and the apparent one is totally different. I hope you might have understood. When the ray of light, now I'm reading the student answers. So rarer medium to denser medium. Okay, Amir, good morning, beta. So now light passes from one medium to another medium. Apparent images the false image of the object. It will bend towards the normal. Yes, it will bend towards the normal. When the light ray move from rarer to denser medium, it bend towards the normal. Absolutely correct and absolutely to the point answer you have given. But here the concepts are like this only. Okay, so we need to give first a concept comes conceptual answer like auntie, when the light rays exactly, refraction is also a surface phenomena. The moment light rays tries to enter, what it will experience? It will experience bending because of change in optical density. Since the change in optical density will be there, what will happen? It will start bending towards the normal. Understood? And when it will bend towards the normal, because it's not only exactly light, you are, the rays are going inside, it will be traced out, and then only you will be able to have a vision. That's also the next important point. Come on, the rays are entering and the rays are coming out, and then you are the one who is watching it. Understood? So it's the rays which is entering inside your eyes which will make the things visible. In a dark room there is no rays, so that's why you can't see. Correct now? So here also the rays which is entering inside has to be coming out, and then only it will be. Okay, so I think we have discussed this part. So answer is refraction. Okay, now we are going to understand. So now look at the next part. This part we have discussed. So now we are going to discuss the next section. So what we have discussed here, a pool of water appeared to be less deep than its actual one. That is again refraction, 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 and refraction. So we know most of the answers. Correct now? Now we can see this, the stick is looking bent because of refraction only. Now we will go to the next one, all again refraction. So this is again refraction. So once our concept is ready, we can answer, because now we are heading towards numerical. Okay, Snell's law, we are going to understand speed of light in speed of light in rarer medium and denser medium and content related to it. Absolutely correct. But the question is this one. I want to see a coin. I want to see a coin. Come on, children, answer my this question. I want to see a coin and there is no water inside the beaker. That time I will not be able, but I am not adjusting the eye. I'm keeping my eye there only, and then I just someone is putting water inside the beaker. So if someone is putting water inside the beaker, I am able to see the coin. I'm able to see the coin. What can be the answer? You will say the answer is refraction only, because of the diversion, because of the difference between the real and the apparent one. Understood? Because another part you will say that because auntie, one thing is happening. When the light ray will be entering from one medium to another medium, bending will be there. Since we are exactly growing from air to, we are going from where to where, beta? Air to water. It will bend, the light rays will bend towards the normal. And once auntie it is bending towards the normal, what will happen? Yes, beta, it looks bigger in size. Yes, bigger in size is also one of the concept, beta. So that means what? Real, we can be able to see this. Okay, we can be able to see because apparent one is exactly there. So also now one of the question is, can we know the real depth of the swimming pool? Can we know the real depth of the swimming pool? If I want to know the real depth of the swimming pool, can be able to know the real depth of the swimming pool without diving inside? Come on, children. Say the answer. Without going inside, can we be able to know the real depth of the swimming pool? Very good, beta. The real depth of the swimming pool cannot be known. Very good, very good, very good. But why, beta? Why the real depth of the swimming pool cannot be known? Very good. Why? Because of refraction. Absolutely, very good, beta. So because of refraction only the apparent position only can be. Very good. Because beta, the thing here is absolutely correct. Again, there is a diversion, there is a diversion. So we see the false image. It's, you cannot say a false image. The exactly because of change in medium, refraction occur, so the object appeared to be raised. Either it is a coin or something. Hi Piyush. Either it is a coin or something. It appears to be raised. I hope you might have understood, beta. Huh? Why this is exactly the lemon appear in water appear to be, yes, absolutely correct, beta. When we see from outside, the water seems like low, but it is deep. That's the reason, Piyush. Good morning, beta. So that's the reason, but what could be the reason behind this? So now can we see this is again the real depth and the apparent depth. This is the question I was asking. So here the real depth and the apparent depth, because of, can you see, the moment the light ray entered, it will bend towards the normal. And once it is exactly bending towards the normal, what is actually happening is we cannot be able to visualize the actual depth. We cannot be able to visualize the actual depth, and we will be feeling like the water tumbler or the water exactly present inside the tumbler or some, that is exactly less, but not, it's not like that. That's the conceptual questions we have discussed. Can we see? Yes. So those words of writing which are below the glass slab appears raised due to refraction of light as it comes from the glass slab. I hope you might have understood this concept, beta. Now we will be going for laws of reflection. Now we are going to our technical work, because till now we did not discuss, we were just simply explaining. Now we are going to solve questions, and now because sin I by sin r related questions, MCQs, they are exactly coming. Now our concept is clear. We understood like this and this and this and this will happen. Now are we going to go inside and understand? Now sin I by sin r. Now, are we ready for it? According to first law of refraction of light, the incident ray, the refracted ray, and the normal at the point of incident all lie in the same plane. That's a concept, we all know that. Okay, so it is law of refraction. Why? Because incident, refracted, everything will be lying on the same plane. But angle of incidence and angle of refraction, there is a ratio in that, and this is the second part. Okay, we are going to discuss now. I think my children are able to answer the second part. Can you be able to answer the second part of the law? Because now we have discussed so much about it. I think you people will rule and you people will answer everything. The angle of incidence and angle of refraction, the ratio of sine of incidence to the sine of angle of refraction is constant for a given pair of media. What is the meaning of given pair of media? Given pair of media means two different given mediums. Two different given mediums. Understood? Two different given mediums. The medium can be what, beta? The medium can be any two medium. Air to kerosene. Understood? Air to glass. That can be two different medium. But here we have to understand one thing. When we are talking about two different medium, both the medium will not be rarer and both the medium cannot be denser. One can be rarer, another one will become automatically denser. If first one is denser, another one will become rarer. So that means what? Angle of incidence will not be equal to angle of refraction. Angle of incidence will not be equal to angle of refraction. But yes, angle of sin I by sin r will become constant. Sin I by sin r will be giving you constant, and that time, bless you beta, I am in south beta, in two different places, in two different places. God bless you. Okay, so different transparent medium, yes, but it will be exactly denser and rarer. It will be different, now denser and rarer. There we have to understand the difference. I hope you might have understood better. So now look here. So I have concluded one thing. I don't know I am correct or wrong. You people can answer because you are listening me. I concluded that since angle of incidence is not equal to angle of refraction, then definitely refractive index can be greater than 1, can be greater or can be less also. So is it correct? Is it correct? Can you tell me? Because now you have understood everything. Incident angle and refracted angle. Incident angle and refracted angle. Either incident angle can be greater. Now listen, I am not knowing anything. I forgot everything. Now I want you people to answer my question. Are you ready to answer my question, beta? So there will be two cases. One case will be when angle of incidence will be greater than angle of refraction. This is first case. Second case will be when angle of incidence is less than angle of refraction. Can you tell me, beta, which one is the first case and which one is the second case? When this is happening, this is when this case is happening, angle of incidence is greater than angle of refraction. What are the two mediums? What is the first medium and what is the second medium? Come on, children, you can answer. Think nicely. When angle of incidence is greater than angle of refraction, Ranjit, when angle of incidence is greater than angle of refraction, then first medium is rarer or denser? Absolutely correct, Ranjit. Super. The first medium is rarer. So incident angle is bigger. The second medium is what, beta? Denser. The second medium is what, beta? Denser. Absolutely correct. Very good. So the light ray will be entering from rarer medium to denser medium. Very good, beta. Very good question. So here the answer is rarer to denser. Now, beta, here when angle of incidence is lesser than angle of refraction. Now this time what it is the what is the answer, beta? What is the first medium? Medium 1 and medium 2. What is medium 1 and what is medium 2 here? Medium 1 is denser or rarer in second case? This medium 1 is what, beta? Denser or rarer? Come on, go for it. Medium 1 is what? Denser or rarer? Medium 1 is denser. Understood? So, incidence angle is lesser. Medium 2 is rarer. So, is exactly get it. So denser to rarer. In second case, it will become what beta? Denser to rarer. It is exactly going to be denser to rarer. Now we are going to understand another important point. One simple question I am starting with. Okay, a very simple question. The incident angle is 60 degree. Okay, the refracted angle is 30 degree. We need to find refractive index. First question itself, simple question I am asking. Refractive index we need to find. Now I am telling what is the value of sine 30 degree and sine 60 degree, because it's Snell's law. It is dependent on sin I and sin R. Can we go for it? Yuva, good morning beta. Good morning. Sorry. Yuvra, good morning. Now sine 30 and 60. Can you tell me beta what is the value of sine 30 is? Sine 30 is 1 by 2. 1 by 2 and sine 60 is root 3 by 2. That is 1.732 by 2. Got it? 1.732 by 2. So how much? So 0.866 here. And here it is 0.5. Then beta. Good morning beta. 100% you contact me beta, you contact me. I just started new. We will be definitely contacting me. Just drop some messages, huh? Good morning Surya. So now look here beta. So this is exactly sine I and this is sine R. So angle of incidence is 60 degree, angle of refraction is 30 degree. Can you tell me what is the medium, rarer to denser or denser to rarer? Rarer to denser or denser to rarer. That means what? When the light ray is entering, this is making 60 degree and now it is making 30 degree. Say, rarer to denser or denser to rarer? हाँ बेटा, स्नेल्स लॉ में कुछ नहीं है, वो टोटल रिफ्रैक्शन के स्नेल्स लॉ में कुछ ज्यादा नहीं करना है तुमको. साइन आई बाई साइन आर, सबसे पहले तो आई और आर को समझो, सारा कहानी वहीं पे खत्म हो जाएगा. सिर्फ एक सिंपल कॉन्सेप्ट लो कि जो एंगल ऑफ इंसिडेंस जब ज्यादा होगा एंगल ऑफ रिफ्लेक्शन से, मींस द लाइट रे विल बी कमिंग फ्रॉम रेयर टू डेंसर. ठीक है बेटा, एब्सोल्युटली करेक्ट, एब्सोल्युटली करेक्ट. Answer is going to be absolutely correct. Now let's check this one out. We will solve this question. Just 1 minute beta, internet is unstable. Now internet is stable now. Now here we will just write n is equal to, we will be writing refractive index is equal to sine I by sine R. Now beta here I is what beta? Sine 60 degree. Sine 60 degree value is root 3 by 2 and here it is 1 by 2. So directly it will become what beta? Sine 60 root 3 by 2 into 2 by 1. Answer is coming as 1 written. But we actually don't need it because we have written the value. So here I'm just solving the question here itself. Sine I by sine R. Look here beta. Sine I, refractive index is equal to what, right? Sine I by sine R. Okay. So here it is coming as sine I 60 degree by sine R 30 degree. Many things which change in medium also numericals in next class. Into 2 by 1. Cancel. Answer is root 3 and root 3 is 1.732. What is the answer beta? 1.732. Got it? 1.732. I hope you might have understood. Next class directly we will go for numericals. Okay? Different